Hold on to your hats, space fans, because we're going on a journey to the edge of the observable universe. We're talking about a time just 325 million years after the Big Bang. Astronomers have discovered a galaxy called JADES-GS-z14-0. It's one of the oldest and most distant ever observed. Imagine a toddler bench pressing a car. This young galaxy is already remarkably massive and full of elements like oxygen. Thanks to the James Webb Space Telescope, this discovery is shaking up our understanding of galaxy formation. We're seeing processes happening much earlier than expected. Let's dive into the mysteries of JADES-GS-z14-0 and explore how it's changing our view of the universe. Before we get into JADES-GS-z14-0, let's talk about how we know it exists. Imagine spotting a firefly next to a spotlight from miles away. That's the challenge astronomers face. Thankfully, we have the James Webb Space Telescope, JWST. It's like trading in old binoculars for a state-of-the-art telescope. JWST detects faint light from the early universe stretched into infrared. This stretching, known as redshift, measures cosmic distances. Higher redshift means farther away and earlier in cosmic history. JADES-GS-z14-0 has a redshift of 13.2, existing 325 million years after the Big Bang. This era, the epoch of reionization, saw the first stars and galaxies. Observing JADES-GS-z14-0 helps us piece together our cosmic origins. Now let's talk about what makes JADES-GS-z14-0 so remarkable. This galaxy is ancient, but it's no shrinking violet. It's surprisingly massive, containing 1 billion times the mass of our Sun. That's a lot of stars packed into a relatively small space. JADES-GS-z14-0, a galactic heavyweight in its infancy. This challenges our understanding of galaxy formation. It grew much faster than our models predict. There are processes in the early universe we don't yet fully comprehend. Here's another head-scratcher. JADES-GS-z14-0 is surprisingly dusty for its age. Now when we say dust, we're not talking about the stuff you find under your bed. Cosmic dust is made up of tiny particles created in the fiery hearts of stars. These particles are essential for star formation, acting like seeds around which gas and dust can clump together. But here's the catch. Stars need time to form, die, and spread their dust around. So finding a significant amount of dust in a galaxy as young as JADES-GS-z14-0 is unexpected. It's like finding a fully stocked bakery before the wheat has even been harvested. It suggests that the early universe had a rapid and efficient way of producing heavy elements, perhaps through the explosions of massive, short-lived stars. And that's not all. JADES-GS-z14-0 also shows signs of oxygen, another element created in stars. The presence of oxygen further supports the idea that star formation was already underway at a furious pace in the early universe. Section 5. Challenging the textbook picture of galaxy formation. So, how does JADES-GS-z14-0 stack up against our traditional understanding of galaxy formation? Well, it throws a bit of a wrench in the works. Our previous models, based on observations of closer, more mature galaxies, suggested a more gradual process. Imagine a slow and steady waltz, where galaxies elegantly pirouetted through space, slowly gathering material and forming stars. JADES-GS-z14-0 is more like a mosh pit, with things happening much faster and more chaotically than we anticipated. This isn't to say our previous models are entirely wrong. They still hold true for a wide range of galaxies. But JADES-GS-z14-0 tells us that there are alternative pathways, especially in the early universe, where conditions were vastly different. It's like discovering a new species that completely changes our understanding of the tree of life. Section 6. Cosmic Dawn versus Cosmic Noon, a tale of two eras. To understand this discrepancy, we need to consider the different environments of the early universe compared to what we see today. The universe was a much denser and hotter place back then. Think of it like a cosmic pressure cooker with conditions ripe for rapid star formation. This era, known as the Cosmic Dawn, was a time of intense activity and change. Fast forward a few billion years to what we call Cosmic Noon, and things have calmed down considerably. Galaxies are more spread out, and the rate of star formation has slowed down. It's like comparing a bustling city center during rush hour to a quiet suburb at midnight. The pace of life is different, and so are the processes that govern how things work. JADES-GS-z14-0 gives us a glimpse into this earlier, more chaotic era, challenging us to rethink our assumptions about how galaxies form and evolve. Section 7. The implications of rapid growth. The discovery of JADES-GS-z14-0 has profound implications for our understanding of cosmic evolution. It suggests that the early universe was far more efficient at forming stars and building galaxies than we previously thought. This, in turn, has implications for the timeline of the universe. If galaxies were already forming and evolving at such a rapid pace just a few 100 million years after the Big Bang, it means that key events in the universe's history, like the reionization of hydrogen, may have occurred earlier than previously estimated. Furthermore, the existence of JADES-GS-z14-0 raises new questions about the role of dark matter in galaxy formation. Dark matter, the mysterious substance that makes up the vast majority of the universe's mass, is thought to provide the gravitational scaffolding upon which galaxies form. The rapid growth of JADES-GS-z14-0 suggests that dark matter may have been distributed differently in the early universe, perhaps in denser clumps, allowing galaxies to assemble more quickly. Section 8. Unraveling the mysteries of the first stars. The discovery of JADES-GS-z14-0 also sheds light on the nature of the very first stars, known as population 3 stars. These stars, formed from the primordial hydrogen and helium that emerged from the Big Bang, were likely behemoths, hundreds of times more massive than our Sun. These stellar giants lived fast and died young, exploding as powerful supernovae that seeded the early universe with the heavier elements necessary for the formation of planets and ultimately, life itself. While we have yet to observe a population 3 star directly, JADES-GS-z14-0 provides tantalizing clues about their existence. The presence of dust and oxygen in this early galaxy suggests that at least one generation of stars must have already lived and died, enriching the surrounding gas with the products of their nuclear fusion. By studying the properties of JADES-GS-z14-0 and other early galaxies, astronomers hope to learn more about these elusive objects and their role in shaping the universe we see today. Section 9. The unending quest to understand our universe. The discovery of JADES-GS-z14-0 is a testament to the power of human curiosity and our relentless pursuit of knowledge. It reminds us that the universe is full of surprises, waiting to be uncovered. Each new discovery, like pieces of a cosmic jigsaw puzzle, helps us paint a more complete picture of our cosmic origins. And this is just the beginning. With the James Webb Space Telescope and other advanced observatories coming online, we are entering a new golden age of astronomy. We can expect even more groundbreaking discoveries in the years to come, challenging our assumptions and expanding our understanding of the universe and our place within it. The universe is vast and mysterious, but with every new observation, we come one step closer to unraveling its secrets. Section 10. Keep looking up. In the words of the great Carl Sagan, somewhere something incredible is waiting to be known. The discovery of JADES-GS-z14-0 is a perfect example of this profound statement. It shows us that the universe is full of wonder and that there is still so much more to learn. So the next time you look up at the night sky, remember that you are looking back in time. Each twinkling star, each faint smudge of a galaxy has a story to tell. A story of cosmic evolution, of star birth and death, of the intricate processes that shape the universe we call home. Keep asking questions, keep exploring, and never lose your sense of wonder. The universe is waiting to be discovered.